Thanks for joining me on Fascinating Frontiers, episode 116, coming to you on June 29th, 2026. Starting the week with the latest from space and science. Supermassive black holes keep flinging radio-emitting material into space years after swallowing a star, showing their appetites stay active long after the initial feast. Very Large Array monitoring of dozens of stellar tidal disruption events revealed radio outbursts long after the initial optical flare. The delayed emission indicates the black hole is ejecting portions of the disrupted star at later times. These bursts allow astronomers to track changes in accretion state in real time. Very Large Array data show material is still being expelled long after the initial optical flare fades, indicating the accretion flow remains unstable. The timing of the flares lets astronomers watch how the black hole's feeding rate changes over months to years. The next step is to monitor a larger sample to learn whether every disruption produces delayed outflows or only a subset. If the sun were compressed to the size of a city, its mass would still fit inside a neutron star. A supermassive black hole at a galaxy's center packs millions or billions of solar masses into a region no larger than our solar system. When a star ventures too close, the black hole's gravity stretches it into a stream of gas that falls inward and forms a temporary disk. Months or years later, some of that gas is flung outward again in narrow jets or winds, producing bright radio emission as the particles spiral in magnetic fields. One measured delay reached several years, showing that the disk can store and later release material on timescales far longer than the initial flare. We still do not know what suddenly changes inside the disk to trigger the ejection after such a long pause. Now shifting to another case where early universe structures are proving more mature than expected. James Webb Space Telescope images captured a massive, densely packed galaxy cluster forming earlier than models predicted. The structure appears at a time when the universe was roughly half its current age. Astronomers note the cluster's density and maturity challenge current ideas about how quickly such systems assemble. Follow-up observations will target member galaxies to measure star formation rates and dynamical state. Radar sounding of Europa analogs on Earth has clarified how the moon's ice shell may trap or exchange material with the subsurface ocean. The work identifies layering and potential fracture zones that could connect the surface to the ocean below. These features matter for future missions seeking biosignatures. NASA's Europa Clipper will carry its own ice-penetrating radar to test the models. Researchers mapped 18,000 star-forming complexes in spiral galaxies to quantify how young stars inject energy and momentum into their surroundings. The survey shows feedback strength varies with local gas density and stellar population age. Results will feed into simulations that track how galaxies regulate their own growth. Next steps include extending the analysis to more distant systems with JWST, from early galaxy assembly to two planets that also formed under surprising conditions. Astronomers discovered a pair of extremely low-density giant planets whose average densities fall below that of candy floss. The worlds were weighed during Antarctic winter observations that captured their mutual gravitational tugs. Both planets orbit the same host and perturb each other's transit times. The team is now modeling how such diffuse envelopes can persist against stellar irradiation. Observations show a giant planet altering the magnetic activity of its star through tidal and magnetic interactions. The effect reverses the usual one-way relationship in which stars dominate their planets. Data come from long-term monitoring of stellar chromospheric emission and planetary orbital parameters. Researchers plan continued spectroscopy to track how the interaction evolves over multiple orbits. JWST transmission spectra of a warm, inflated world revealed absorption features consistent with sodium and potassium chloride clouds. The planet's unusual pink hue matches laboratory spectra of these salts under the expected temperature and pressure conditions. The detection marks the first clear evidence of exotic cloud chemistry on a giant exoplanet. Follow-up observations will search for additional condensates and map cloud patchiness. From exotic planet formation to a more routine but commercially important satellite launch, SpaceX launched the SXM-11 satellite aboard a Falcon 9 from Cape Canaveral at 0225 UTC. The spacecraft, built by Maxar, will join the SiriusXM radio constellation. The first stage touched down on the drone ship, a shortfall of gravitas, after separation. Deployment of the satellite was confirmed shortly after reaching its transfer orbit. The mission forms part of an ongoing refresh of the geostationary broadcast fleet, from operational satellite fleets to a startup restoring its own commercial service. British startup SatVu declared HotSat-2 operational on June 29, restoring revenue-generating services after its first satellite failed in 2023. The spacecraft delivers high-resolution thermal data for energy, industrial, and environmental customers. Operations resumed from the company's existing ground segment. SatVu expects the satellite to support multiple contracts already in the pipeline. 2 strong quakes struck Venezuela last week. The NASIR mission supplied radar imagery that shows how the ground moved during the events. NASA's Disasters Response Coordination System activated to distribute maps and data products to emergency teams. The imagery helps responders assess damage and plan relief routes. Additional data releases are scheduled as processing continues, from one company's recovery to a national effort scaling an even lower orbit regime. A new industry alliance will coordinate development of satellites operating below 300 kilometers altitude. Several Chinese spacecraft have already demonstrated sustained flight at these heights using continuous propulsion. The group also supports propulsion startups seeking investment for drag compensation systems. Sustained VLEO operations could enable higher resolution Earth imaging and lower latency communications. From new orbital regimes to quiet pockets of calm gas near the galactic center. Atacama Large Millimeter Submillimeter Array observations uncovered a region of slowed, settled gas inside the turbulent Milky Way center. Within this pocket, material appears to be collecting into dense cores that may become new stars. The findings suggest star formation can proceed through familiar processes even in extreme environments. Further Atacama Large Millimeter Submillimeter Array maps will search for additional quiescent zones and measure their magnetic and turbulent properties. The cluster MESJ0018.5 plus 1626 appears as a single X-ray source, but is actually 2 systems colliding head-on. Radio and X-ray data reveal the ongoing merger and the resulting shock fronts. The alignment offers a rare view of cluster assembly in progress. Additional multi-wavelength observations will track how the merger redistributes hot gas and dark matter. Los Alamos researchers confirmed that a pair of long-duration GRBs originated from neutron stars collapsing into black holes rather than from typical collapsars. The events were identified through detailed modeling of their light curves and host galaxy properties. The finding expands the known channels that produce long GRBs. Further gravitational wave searches will look for similar progenitors. A new study explores how the sun's gravity could magnify light from compact stellar remnants, enabling resolved images of their surfaces or accretion disks. The technique would require spacecraft positioned 550 AU or farther from the sun. The same alignment geometry already proposed for exoplanet imaging can be repurposed for these targets. Mission concepts are now evaluating required pointing stability and integration times. Before we go, keep an eye on continued Very Large Array follow-up of tidal disruption events and the next round of James Webb Space Telescope cluster observations expected in the coming months. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow. And if you'd rather watch than listen, find us on YouTube at NARA Network. Links in the show notes. And before you go, this show is part of the NARA Network, a family of daily podcasts on tech, science, and markets. Each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. Unintended consequences. True stories of good intentions that backfired. Find every show free at naranetwork.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.